Force due to gravity, part 2. Okay, so let's calculate the force due to gravity at the surface of the Earth on an object of some mass m. We're going to leave that one as a variable. Okay, here's our starting equation. And now I'm going to plug in my value for big G, 6.67 times 10 to the negative 11th. I'm going to leave mass 1 as this object of mass m that we don't know. The second number on that line is 5.98 times 10 to the 24th. That's roughly the mass of the Earth in kilograms. The denominator, 6.38 times 10 to the 6th squared, is the radius of the Earth plugged in and then squared. If you put this in a calculator, you'll actually find that you get the magnitude of the force due to gravity on an object of mass m is 9.80 m. Huh. That number sure looks familiar. So here's a different sample question. This one's more about mathematical reasoning. The gravitational force between two objects is F. If I double the mass of one of the objects, what is the new gravitational force? If we start again with this equation, if I double one of the masses, in order to keep it an equation, I have to do the same things to both sides, right? That's basic algebra. So if I double one mass on the right, I also have to double the force to keep my equation balanced. So the new force is 2 times that original F. Okay, similar question, but now if I double the mass of both of the objects, what is the new gravitational force? Same starting equation, but if I double both the masses, all right, I have to double the force twice because I've multiplied 2 on the right side and then 2 again. So multiplying 2 times 2 is 4. So my new force is 4 times the original force. All right, one more of these, but now the gravitational force between two objects is F. If I double the distance between the objects, what is the new gravitational force? Same starting equation, all right? If I double the distance, now it's in the denominator, okay? And the distance is squared. So in order to keep the equation balanced, I have to divide the force by 4 because 2 squared is 4. So my new force is F divided by 4. Okay, so this relationship where force is proportional to 1 over r squared, all right, that's what we know as the inverse square law. Inverse because it's 1 over and it's the distance squared. So force is inversely proportional to the distance squared. This means if I double my distance, my force is cut in 4. If I triple my distance, my original force is divided by 9. So this is a graphic from a website called The Physics Classroom, which we'll actually be looking at later. But hopefully this graphically shows you the effective mass and the effective distance on the force due to gravity.